In graphing the absolute value functions, we saw a pattern that we're actually going to see repeat over and over again, and it was this. First, we learned the basic shape of the graph, and then learn how to find some key points that let us place that basic shape. But that raises a couple of interesting questions. Specifically, the questions that it raises are, well, how do we know when the basic shape applies? And, in general, how can we know what's actually happening with those key points? And the answer to that is that there is a general method of taking one specific function and growing it into an entire family of functions. These types or families of functions that all have basically the same graph will always be some base function composed with something linear. Maybe two linear functions, one inside, one outside. But we'll just have the base function and then a bunch of linear stuff. And it turns out that when we're working within such a family, we can get the graph of any of the functions in the family by what are called geometric transformations of the graph of the base function. Now, depending on the exact kind of geometry class you took, you might be more or less familiar with these geometric transformations. I'm just going to kind of list what the transformations are here, and in the coming videos, we'll see how various parts of the expression translate into various transformations of the graph. So our three basic geometric transformations are translation, which consists of just moving something around without changing its shape. Scaling, which consists of either stretching something or squishing it smaller. And reflection, which is just flipping something. Now, you may be aware of another geometric transformation, which is rotation. Rotation is just turning something. But it turns out that that doesn't really come up when we transform the graphs of functions. And the reason why has to do with the fact that the x and the y-axis really stay fixed. We'll give a brief mention to one specific rotation, but for the most part, rotation will not be relevant to our interests. The three transformations we're going to be interested in for the graphs of functions are translation, scaling, and reflection. And that's what we'll see in the coming videos.